The system also simulates distortion before and after support removal, as well as distortion after heat treatment. These distortion predictions are what is used to generate the compensated geometry that you would then use to mitigate these issues. Now, as with Sonata, SimCenter 3D AM can also alert the user to possible recoder collisions with information about the approximate layer that the issue might occur in. Now, this is of paramount importance to the machine operator, as we sort of mentioned before, because recoder collisions don't just mean a failed print, but they also can damage the machine, adding another layer of cost to the process. And finally, as I also mentioned earlier, SimCenter 3D AM can also calculate compensated geometry to address distortion issues. So this geometry can then be easily integrated back into the build tray because of the inherent associativity between the NX and SimCenter tools. All of the compensated geometry is created using the same data model and all within the NX tool set, so there's no translations or file drops or other such migrations of data necessary to use that new compensated geometry in your build tray for printing. So just to review, SimCenter 3D Additive Manufacturing is embedded in the NX Additive Manufacturing Framework. It's launched from the build preparation step in NX, and it provides a streamlined workflow to easily define the simulation of the build process. It's able to simulate temperature with and without powder, simulate the probability of overheating, predict distortion before supports, after heat treatment, and as built. It can generate compensated geometry to mitigate distortion. It can predict the occurrence of shrink lines, and it can predict and warn about recoder collisions. Now, so far we've talked about Sonata and SimCenter 3D Additive Manufacturing as tools that can help a manufacturer move quickly up the knowledge acquisition slope. Siemens also has a third tool on the horizon. It's to help you aid with you getting that first time right print. We're currently working on a tool we call the NX AM Path Optimizer, and that uses simulation again to identify local overheating, and then it corrects the deposition path to address those issues. So while both Sonata and the SimCenter 3D AM tool simulate manufacturing performance by taking a wider angle view, the NX AM Path Optimizer zooms in and looks at the process at a much finer level, including the performance of the hatching and slicing algorithms. So, unlike Sonata, which alleviates distortions by optimizing the orientation of the part, and unlike SimCenter 3D AM, which alleviates distortions by compensating part geometry, this tool attempts to alter the material deposition path and machine parameters to correct for very localized overheating. I like to call this hyperlocal overheating. So my definition, hyperlocal overheating, it's a real issue for AM because it can be the root cause of some of the problems we talked about earlier. So a distortion might occur because of these things, as we see in the images here on the left. But again, it can also cause things like small deformations and overheating that causes large deformations, leading to things like recoder collisions. So if we look at the images here on the left, we can see how the part has deformed in the Z direction. And this is reflected by the part extending through the new layer of powder added by the recoder in the picture on the bottom. So if you look closely, you can see streaks in the powder where the recoder touched the underlying part. Now on the right, we can see a magnified detail of a printed. You can see the materials have been deposited in sort of globs rather than nice uniform lines. And both of these issues were caused by hyperlocal areas of overheating. So overheating at such a small scale is honestly difficult to simulate because it must take into account the physics of the melt pool. And of course, there are a lot of variations that can affect the melt pool, such as the deposition path, what we call the hatching strategy, as well as machine parameters like laser power and dwell time. So the NX AM Path Optimizer attempts to alleviate some of these issues by simulating the actual deposition of material according to the machine program. Simulation finds the areas of concern And the deposition path and parameters of the machine are then altered to attempt to correct for this. So here we can see some results. On the left, this is the picture we looked at just a minute ago, the original part with the magnified area in the red box. Now again, in this case, we see this clumping and globbing of the material as it's deposited. Whereas on the right, we see the corrected path and parameters coming into effect. The deposition is much more uniform, resulting in much cleaner geometry. Again, here's the example we saw earlier, but we're seeing a wider picture of it. And what you can tell here is that we've run 2 copies of the same part in the same build, one with an optimized path and one without. So you can see the distortions in the Z direction that we saw before in the original part at the top, causing those streaks where the recoder touched the distorted geometry from the previous layer. However, you can also see that those problems are absent in the path optimized part at the bottom side of the build tray, where we get a nice smooth distribution of powder for the next deposition layer. So the NXAM Path Optimizer is technology that's currently in beta, so it's not yet a product, although it is slated to be released soon. And when the product is released, it's going to be another tool in the toolbox that customers, mostly at the journeyman and master levels, can use to reduce their failure rate even further than what they have today. So what you can see here is Siemens sort of attacking the problem of high failure rates for additive manufacturing on several different fronts. And our goal is to have a suite of tools that helps our customers at every level of the AM learning curve move higher up that pyramid towards true mastery of the AM process. Now it's worth mentioning that the tools we've been talking about, like Sonata, SimCentra 3D, Additive Manufacturing, and our forthcoming NXAM Path Optimizer, are part of the Siemens end-to-end integrated software process for additive manufacturing. So our corporate strategy centers around the digital twin being the basis for real production. And our end-to-end AM solution is built upon the digital twin, and it removes the need for data translations and broken process chains. However, Sonata, SimCentra 3D AM, and AM Path Optimizer are only parts of this overall solution. Now, these tools exist in parallel with other solutions for design for additive manufacturing, build tray setup, and connecting to additive manufacturing hardware. So, for example, in the virtual product area, well, we've got design validation tools that also assist with alleviating print failures. I didn't talk about those tools today, but they are appropriate for all levels of the AM knowledge acquisition journey, even down at the apprentice level. And those tools look for simple geometry issues like excessively thin walls, excessive overhang, or completely enclosed voids where powder or supports might be trapped. Now, all of these solutions in their entirety complete the AM workflow from the virtual product through virtual production and into real production where the physical product is then produced. If we look closer at the portion of the portfolio that aids in printing first-time right parts, we can see that the tools we talked about today exist in the virtual production and real production areas of the product suite. The solutions we've talked about here are part of a series of companion tools that all work towards allowing Siemens customers to get a first-time right print in an industrial fashion. So the question is, how will your company move up the additive learning curve? Are you going to climb the mountain the hard way by investing large amounts of time and money to acquire knowledge organically? Or will you invest smartly in software tools to aid in that process and protect against those hidden costs we talked about, like expert brain drain? Regardless of where you are in your AM journey, Siemens Solutions can help you move up the learning curve to realize lower failure rates and a better return on your additive manufacturing investment. Printing first-time right parts is definitely a lofty goal, but Siemens Solutions can help you attain additive manufacturing mastery so that you can design and print parts at an industrial scale.